The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, ladies and gentlemen, from the Passive Virtualization Group. This is Tom Norman. We welcome you to our May presentation. Paul with Windocs is going to be with us today. He's going to show us a different way to do DevOps. I was just having a discussion with him that I actually pretty much do similar stuff with him, so I definitely need to look at his software myself. So I'm excited to see what he has to offer. And Paul, I'll let you take it away.
All right, Tom, thank you very much. Can you pass the presenter role over to me?
I sure will. I haven't done that yet, have I? Sorry about that. And did it come over to you?
No, I'm not seeing any change.
All right, let me try that one more time here. It says make the presenter. It's not being very nice here. Definitely click on make the presenter, please. All right, let's see if I can try this again. Hold on, folks. Sorry about this. There we go, Paul. Should have went over to you now.
Okay, very good.
My mouse wasn't working very well.
I've got it. Okay, so you
Okay,
should be able to
see.
Yeah, very good. Oh, thanks, Tom. This is Paul Stanton. I'm a co-founder at a company called Windocs. And what we're going to talk about today is the use of database clones as part of an Azure DevOps workflow. And we're going to cover a number of topics today. Relating to a continuous integration pipeline. And several of these kind of are related to virtualization. So as we consider a Azure DevOps pipeline or continuous integration, there are really three primary technical decisions to be made. And the one that we're really focusing on today is the first item on this slide, and that is whether you want to build databases from source control or use database clones with migration scripts. And then if you're using database clones, the additional question becomes, well, how are you going to source those? Database clones can be built using SQL Server backups or cloud storage, as well as use of storage arrays. Now, we're going to focus on this session today. I'm going to talk about the benefits of working with database clones. So we're going to get into this in greater detail. But in addition to that decision, you also face a choice of what form of source control you're going to work with. We're going to focus on this session on just use of Git, but you can also use additional products like Redgate source control, Liquibase, and others that work with Git and provide a richer feature set. The ability to do schema compare and to generate migration scripts, or not migration scripts, but yeah, generate state-based scripts to move to production. And then the final issue that you need to deal with in a continuous integration plan is whether you're going to do that with conventional SQL Server instances, or whether that might be the reason you get into looking at SQL Server containers. Now, these three are the primary decisions that will be made. And then, of course, there's the fourth issue is what CI server will you use? And again, today we're going to obviously focus on Azure DevOps. And I'm going to use containers, and we're going to talk about the pros and cons of containers compared to instances in this use case. Now, this discussion is really one that can be applied to containers as well as instances, and it's not limited to Windocs. Redgate SQL clone is widely used for database cloning, and there are also PowerShell scripting-based approaches to database clones as well. So bear in mind, you can do this with Windocs. You can also do it with various aspects of Redgate SQL clone and just plain PowerShell scripting. And now the reason we're going to focus on database clones today is that they are arguably a superior artifact for development and test processes. We see them enabling higher quality releases, and you're going to generate higher quality releases working with database clones simply because you're going to identify performance and data related problems in a development and test process earlier in the process than you would if you're doing a schema compare and building a development database based on source. Other things to consider in a CI process is that when you're working with a multi-database environment, building from source will take additional time. It also represents additional complexity if the databases need to be built in a sequential order. So in the end analysis, from my point of view, you're going to have a more reliable continuous integration process using clones than using a built database. And to quote a number of my customers, people that I'm working with, a very senior Fortune 500 architect told me just last week, he says, why on earth would you work with anything but a secure copy of the production database if it were available? And that's, I think he's right. I think that is, clearly an option to consider today. But having said that, it's really up to whoever is implementing the CI process to make some of these choices. But once you've made a choice, and I'm going to assume that you're looking at a database clone process, then you have to look at some of the other aspects of a CI pipeline. And what we see in a continuous integration pipeline or Azure DevOps development process, we really see a 2 or 3 step process where most organizations today are moving from a shared manual process, oftentimes with minimal source control. Database developers are developing the scripts and they're passing them along to the people in test to apply those. In the left-hand side, these environments typically exist for weeks or even months at a time. And what people are doing is they are modernizing with database clones, and they either modernize with those database clones and combine them with Git, and it either runs on developers' workstations or they're running on containers. Now, in this middle part of the adoption process, the lifespan of those environments is not terribly faster. I see that they typically exist for days or weeks at a time. They do deliver isolated self-service environments, and developers are much better able to stay in sync with each other in terms of commits to the repo. We're going to talk more about that. But in the middle case, there's nothing that compels containers over instances, frankly. But when you take the additional step of moving to an automated multi-stage testing environment, which is what you're going to be doing with Azure DevOps, that's when scalability really comes to the fore and speed of the build process. And this is really where containers become a clear advantage over instances. A single 4-core VM, and I'm going to demo a VM shortly, can support up to 50 SQL Server containers. So a 4-core 16 or 32 gigabyte configuration can support up to 50 environments with a 30-second build time. Those environments also are configured on delivery, and they're torn down when the work is done. In an automated testing environment, the environments typically have a lifespan of some number of minutes. And this is where working with instances really becomes problematic. In the lower right-hand box, if you're working with instances, you're going to have to provision a number of them to support the test volume. And you're going to be dealing with configuration drift and errors that result from configuration problems. You're going to have to maintain these VMs, and ultimately you're going to incur significantly longer build queues and higher costs. Hey, Tom, I'm going to pause here for a minute. I want to just ask if there are any questions.
No questions yet, Paul.
Okay. And I would encourage you guys to ask questions as we go. Let's make this as interactive as we can. So what we're going to take a look at today then, we are going to be using containers, but these containers are nothing more than named instances on a Windows server host. And we're going to be delivering database clones. In this case, these are Windows VHD-based clones, but we also support a variety of storage array systems. We're going to be pulling code from a Git repo, and we're going to be combining that in a complete continuous integration process. And this can be used as a backend to any of the popular scalable front ends. People use this with OpenShift, Azure Web App Service, any variety of forms. But so now we've decided we're going to work with database clones. We're using Git, and I may build a database clone image based on yesterday's production database environment. And as a developer, we have to figure out, well, how on earth are we going to work with the migration scripts that we're going to be committing to a source repo? The migration scripts obviously require an order when they are applied to implement whatever the feature or hotfix is that we're working on. And one way to manage and order the migration scripts is to use a PowerShell script to do so. So in this case, I have a PowerShell script. Oh, I've got a typo. It should be order scripts.ps1, not SQL. But what we're going to do is we're going to use a get content and set content commands. We're going to pipe the get content of a number of scripts, and we're going to create a concatenated and ordered feature A .SQL script. And so this is a process that we're going to use in this workflow. And we're going to incorporate that into the Docker SQL Server image. So what we have here is a image. We're using SQL Server 2017, where we have a database clone that's built on a backup of the customer's database. We're running a data masking script on that database environment. And then at runtime, we're going to clone our source repo into a scripts folder in the container. So the run git.exe clone the URL to scripts is pulling that repo. And then at runtime, the next thing we're going to do is we're going to run that PowerShell script, the order scripts.ps1, and that's going to generate that feature A script. Now, once that is done, then the Azure DevOps pipeline will make RESTful API calls to run containers, to run the tests, and will use the an environment variable to determine which scripts are applied. And the environment variable is built into the Docker command line. In this case, we include an environment variable called run, and the script or scripts that we want to apply for that test are applied using these environment variables. Now, so if you go back now, what we've done is we've built in an automated process to concatenate and order scripts Now this PowerShell script that we've talked about, the order scripts.ps1, this is going to be updated and committed to the repo whenever a new migration script, a T-SQL script, is committed to the repo. And in this way, whoever's working with the repo will always have a feature a.SQL that can be run when they clone the repo. So the PowerShell script is being updated and committed along with the T-SQL migration scripts. We can build that into our Docker container image. The same commands to clone the repo and to run the order scripts can be applied with instances just as well as they can for a container. So those bottom 2 lines in red would be the equivalent to what a developer would be running if they're working with a local instance. And then, of course, if you're using containers, you can organize the scripts that are applied using the Docker command line. And with that, we're going to go ahead and we're going to go and take a look at how this works. Are there any questions at this point, Tom?
Yeah, there's one. With GDPR and California laws, how do you mask data under dev test that uses a copy of production? So we saw that script, so you might want to go into that a little bit in depth when you get to it.
Well, you mask the data using any of the standard methodologies that you use today for any database. It's no different when you're working with a database clone than it is with any database. You know, so Redgate, any number of vendors offer data masking tools. Many customers use T-SQL scripts to implement data masking to obfuscate sensitive data. So when it comes to GDPR and data security, you use all the same tools that you normally would. Now, in my example, we're using T-SQL scripts, but you're not limited to that.
Yeah, just to fill in the group, we actually use Windows functions to basically scramble the data, take it out of the database, shake it all up, and put it back in. So that's how we actually scramble data. Each field is done individually, so they don't come back the same.
Yeah. Yeah, now, so we've just been talking about a Azure DevOps process. We're going to get to an automated Azure DevOps pipeline in a minute, but the whole process begins with developers who need a self-service environment. So part of what we do here at Windocs is we provide a web UI to simplify that for the developers. And you can see that we have a clone image. This image is the same that we just looked at in the presentation. You can see in this case, we're working with SQL 2017. I've got a customer's database. We've run a data masking script on that database, and then we're running a git clone command, and we're cloning the repo into the scripts folder in the container, and then we're running the PowerShell script. In this case, it's not order scripts, it's combined scripts in that environment to create the resulting script. Now, in this case, the script we're producing is all.SQL. And so we've built that image, and you can see using a standard Docker command line, you can see the containers that are available. You can also see what images are available. And if I wanted to create an image, and let's go ahead and run that concatenated script. That's how we would do it with a command line interface. Now, the developers will typically use that web UI to generate their environments. And that way that once the image is created, then the developers can proceed to do their development. They can be committing to the repo, and they can get the project to the point where it's ready for test. And this is the important aspect of this, is a self-service environment for developers so that you can feed the project into a continuous integration process. Now, so in review here, what we're doing is we're provisioning a container, SQL Server 2017 container. It's a full installed named instance on the host. It's going to have a mounted customers database. It's going to include the clone of that repo, and we're going to have run that PowerShell script to concatenate the files into the all.sql and generate the all.sql file. So let's go ahead and start this container real quick. Each container has a unique container ID. You can manipulate or start or stop the container using the first couple of digits of that ID. You can also see the containers running at a port on that host. And I'm going to go ahead and start up Management Studio so we can access this environment. So we're going to access instance 10,006. This would be a typical of a developer's experience, right? They're going to develop and access containers, and there's our database, and that database will include the results of that all.sql script that was run. So this is a full read-write supporting environment. This gives developers the ability to experiment with things. If they do a destructive test, they can easily delete the container and replace it just as quickly as we just produced this environment. So you should begin to appreciate that this is a very agile environment. You can delete containers, you can replace containers. In fact, our recommended practice is that the developers would provision a fresh container whenever the repo is updated, which is essentially what the automated CI pipeline does as well, if you set it up that way. So any questions at this point, Tom?
Yes, we got one more. It says, can you tell me what is in the .sql file? Is there a publish script that deploys changes to the database?
Yeah, let's go ahead and take a look at that. So if we go into the Windocs containers directory, the containers directory, by the way, can be put onto a separate disk. The containers themselves are pretty lightweight. They're 200 to 300 megabytes each. The databases are on a separate disk, so you can work with large environments. And let's go to this latest container here, and you can see we've got the scripts file in the containers folder, and the concatenated file is just, it's trivial, admittedly, but it shows that a T-SQL script was generated and run on that instance. So that's the other thing that developers can do, obviously, is they can deliver the container without any of the repo scripts run. So if I just do a Docker create clone, I'm going to get the container with the clone database. I can clone the repo to my local workstation, and I can run whatever scripts I want on the container via SSMS or other data tools. So I've got complete flexibility in terms of how we work with this environment, and that extends as well to development, staging, and user acceptance testing for that matter, depending on what the needs are.
Okay, I've got some more questions that came up.
Sure.
How do you deal with production size of databases, 1 terabyte productions?
Yeah, in the same way, so the way database clones work, a database clone in the form of a virtual hard drive, the image is a full byte copy of that environment, but that image can support up to 50 or more differencing disks or clones. Each of the clones will have a file pointers to the parent VHD for read-write support. So one full byte copy of the image gives you support for as many clones as you want. We have customers that run upwards to 50 simultaneous terabyte class clones, and they're oftentimes, typically they're using a 4-core machine. So as long as you provision reasonably performant attached, typically we recommend SSD disks. You can support very large database environments for development and test. In fact, I have one customer, and this is done with a storage array. It's not a VHD-based system, but in that case, it's a storage array that's serving up 25 terabyte data warehouse environments. So it really performs very well as long as you have the right back-end disk or storage array support. Does that answer the question?
We'll see if he pops one back in there while we're waiting on him. Then we've got another question. Can a Docker container handle multiple databases, i.e. say a suite of 10 databases that make up the entire product?
Yeah, it's a great question, and yes, it can. And that's really one of the advantages of database cloning is that you can deliver, and I have customers that work regularly. Well, our customers probably average a half dozen databases in an image, but I have customers that run over 30 databases in an image. So you can imagine the complexities of working with that environment dramatically simplified by simply creating that image instead of just the single database. You would be defining 30 lines of databases in the image, and then all 30 of those databases will be available. Now, the default is all 30 would be delivered, but we also include in the web UI, we have a drop-down tool. So if you have a complex environment with 30 databases and a developer only wants to work with, let's say, 5, you can deliver that complex environment. The developers can select the databases that they want to work with and simplify their working environment. But it's very straightforward to deliver large, complex database environments. It's really where database cloning really shines in a enterprise development and test process.
Okay, I don't have any further questions at this point.
All right, so we're going to move on now. So we spent a few minutes here on the local host just to show how the developers will work with this environment. Let's switch over now to Azure DevOps. Here we go. So do you see my Azure DevOps page now?
I do.
Okay, very good. So what we have here is, let's go ahead and take a look at this. So this is based on a free environment. You can see, we've got a repo set up. You can see I've got my pipelines in the form of a YAML file. If I come into the pipeline here and if I click on edit, what we've done is we've developed a pipeline. It's going against the VM that we were just working on. And I've got, a user account and credentials plugged in. You can see here I've got the scripts defined as variables in the pipeline, and we're going against that same clone image. So we've got the script has been parameterized, so to speak. It's in the form of a YAML file. At this point, you can very easily modify and change it. And we make this freely available, so we'll talk about it in a minute. And if you click into a past build, you can see it's a multi-stage process. What we're doing here is we're provisioning a test environment and running unit tests, and then we're running a staging environment and running, more complete integration testing with an application. Now, let's go ahead and kick off a build so you can see it in process. So we're going to go ahead and queue a build. That's the Azure DevOps process. And now if we click in here, you can see that the build is being kicked off. Now, I mentioned earlier, you can set up Azure DevOps so that a build is triggered whenever there's a new commit to the repo. And that would be one of the important ways a pipeline is used, is an automated process, fully automated process. So every time there's a commit to the repo, you can build and you can make sure that that commit passes your automated tests. Now, for many people, the blocking issue for people to get to an Azure pipeline and really be doing effective automated builds is you do need to build out your unit and integration tests. You really need to logically put a test harness together and have a fairly complete suite of tests developed. But what we have here is a pipeline where that's easily integrated. Now, what's happening here is this is hosted on Azure. The other machine is actually on another cloud. I won't name which, but this illustrates as well how a lot of our customers are using Azure DevOps with on-prem machines. A lot of our customers are running their front-end apps on Azure Web App Service and connecting to SQL Server backends that are running on-prem. This works well. It just illustrates how portable these technologies are. And point I want to point out here is that in this, we're now almost 2 minutes into the build, and we're almost done with provisioning the test container and environment and passing those tests. And so now we've just kicked off the staging environment and we just passed the 2-minute mark. And the point here is that in an automated testing environment, one of the keys to success is keeping the build queue down, short, so that developers and testers can get results on the testing as quickly as possible. Now, you can imagine if you have an environment with 6 or 10 databases and you're building those from source, you're going to spend, a half an hour waiting for the build to be available to test. In this case, I could be provisioning terabyte class database clones. I could be provisioning 20 databases, with an aggregate footprint of 2 terabytes, and it would take no longer than we just saw. At 2-minute mark, we would be provisioned, tested, and completed just that quickly. And this, you begin to realize that this really is a game changer for, SQL Server development and test processes. And there we have it. The whole pipeline is done now. Let's take a look at the results of the build. You can see we've got a couple of containers here, port 10,008 and 10,009. I'm going to go ahead, I'm going to copy my credentials because I won't remember them otherwise. Let's go ahead and access this environment. So 54203. And see the results of the complete process. So while this management studio is spinning up, let's make sure that we get any other questions out.
Yeah, there's another one that says, what testing software do you recommend to build out unit test or integration test?
Oh, unit testing is, well, Redgate's got a good testing framework they just released. Other people use Selenium for integration testing. Unit testing is commonly done um, with 2008 user 14 with stored procedures. It's a great question. And I admit I'm not answering it very concretely. Shoot me an email at pauls@windocs.com and I'll get you some further research from our team on what we recommend.
All right, and
so we just access that environment that we built through the DevOps, pipeline. Those scripts will run on this customer's database, and it just illustrates the closed loop. Yeah, go ahead, Tom.
Do we need any other software apart from Windoc and Git?
Oh, there's Windocs and Git, and then of course there's the Azure DevOps pipeline itself. If you're not working with Azure DevOps and the free pipeline that they support, it would involve another CI server, be it Jenkins or Bamboo or others. But yeah, Windocs delivers you the support for the SQL Server containers and the database cloning. So it can be done simply with Windocs and Git.
Okay, that's all the questions for now.
How are we doing on time? Wow, this has really gone quickly.
You're good.
Yeah. So that illustrates, the power of this type of environment. Let's go back, and we don't have to drag this out. Let's go on to the next slide. So, to wrap up, we feel strongly that database clones are really a superior artifact for development. As we've discussed, database cloning really delivers some advantages when you're working with multiple databases. You're avoiding the build process. And by avoiding the build process, you're also avoiding introduction of changes as you move through that development and test process. You're working with a higher fidelity environment that really is going to allow you to identify performance and data related issues. And when you combine this process with containers, you get greater speed, reliability. You're not going to have problems with configuration drift of instances, which are so common. You also, frankly, increase your security. One thing that we didn't discuss earlier is that the database images that we built, so that clone image that's sitting on the Windocs host, that becomes an auditable, reportable record of the images, the security policies that were applied, the users that access those environments, and when those accesses occurred. You end up with a dramatically improved security profile because you've reduced your attack surface because it's all on one host, and you've created a auditable record of what's been going on. So security here really is improved with this process. And then, of course, you have the scalability of being able to provision those containers quickly on that one host. So if you find this interesting, I invite anyone that's interested to visit Windocs. We've got a Azure DevOps page. Whoops, I shouldn't have clicked on that. Visit the Windocs Azure DevOps page, and you can register and download the YAML file that we were just using. let me show you how that YAML file is imported. So I'm going to go back. I'm going to go back to the builds view, and we're going to edit, or no, I'm sorry. We're going to go to repo. So I've gone to the repo, and you can upload a file. So let's see if I can find. Yeah, here we go. So I've got my YAML file, and I can select that. And we can commit it to our repo. And if we come back into builds, yeah, I don't think it's not presenting me with a new build, because the same YAML file is already here on my Windocs demo. But if you were importing the YAML file, normally you'd import that YAML file and you would see a new build pipeline right here. And so I invite anyone that's interested in exploring this type of build process. The VM that we just used is going to be hit by this YAML file. So you can go create a free Azure DevOps account, download that YAML file from the Windocs site, come here to your repo that you will have configured, upload the YAML file, and create your own build pipeline. You're going to have the same experience that we've just looked at here. So you're going to be provided a YAML file with pre-populated with user accounts and credentials, and you can play to your heart's content. Now this is not going to be a permanent thing, but we'll give you a couple of weeks to play with it. If you're interested in carrying that onward, then simply download a free Windocs server from our site, set that up as your target host, and you can continue on. And we just want to provide this because we think it's a great, simple way for SQL Server professionals to get some hands-on experience with SQL Server as part of a Azure DevOps pipeline. Now this pipeline that we just built, this builds, you see we just kicked off a new build. But the pipeline that we built earlier, this is going to deliver, 2 containers. We also have pipelines that can be used to hook up to a .NET app. So let us know what you need, because we probably have the pipeline support for it. And this is just a real simple way for anyone that has a need to bring a solution to supporting SQL Server environments with .NET or other Node.js front-end apps. We've got the support that you need. And if you're interested, just download the YAML, explore it with a personal Azure DevOps account, shoot an email to us at support@windocs.com if you have any issues or questions. And
all right, we have a few more questions here, a couple more questions. So what about TD-enabled databases? Are we going to be able to clone those? What would we do there?
Yeah, we've got support for TDE and column level encryption. Let's just go real quickly to.
What about always encrypted also? Do you have support for it?
Yep. So I'm just going to go real quick to windocs.com. I assume you can see my screen?
Yes, we still can.
Yeah, so I've just gone to windocs.com in our docs section. You can come down into the technical docs, and we've got guides to container security, working with external key managers, TDE, column level encrypted databases, etc. We work with storage arrays, friendly names. I mean, all of our documentation is here online. Directions are generally pretty straightforward, but of course, we're also available, via support@windocs.com to answer our particular questions as well.
Okay, and the next question, without Windocs, it sounds like we lose the DB clone feature. Is that correct?
Well, that's not accurate. So if you go back to the presentation, there's nothing to stop you from using this process. Having difficulty recovering my mouse here. There's nothing to stop someone from using other forms of database cloning with instances. So you can you could use Redgate SQL clone, you can deliver those database to an instance, and you can clone a Git repo, and you can develop and commit a PowerShell script, and you can concatenate the migration scripts as we've described. And you can do all of that with Redgate SQL clone or other cloning tools. We're not the only source of SQL Server cloning. The one specific difference between Windocs cloning and Redgate's cloning is we do support multiple databases in an image. Redgate is cloning of each database individually. And we also support storage arrays, where Redgate is using SQL database files or backups only. But you can use Redgate, you can use other tools to do some basic database cloning. And what we do at Windocs is we combine that database cloning with SQL Server containers, and that's really our calling card. Are there any other questions, Tom?
Yeah, but you'd have to have some type of cloning tool to do it. So you're going to need Windocs or Redgate's the only two that I'm aware of.
Yeah,
Right?
yeah, I think that's a fair comment.
Yeah.
But one of the, we didn't discuss it, but one of the advantages of database cloning is that you can deliver these production databases very cost effectively. So you're saving 99% on storage costs, particularly in a high volume environment where you're doing continuous integration testing. You could be, working with 10 or 20 or 30 copies of a terabyte class database. Well, you're only using 1 terabyte of storage. So it ends up, being economical and generates a lot of savings, in a CI process.
And then someone asked also, do you have an opinion about using Windoc and cloning with SQL Server data tools projects?
Yeah, because the SQL Server containers are simply named instances on the host, you can use any client-side tool you want. It's a good solution that way.
Okay. Let's see if we can get more questions come in. For now, that's basically all of them. As we kind of wait for a moment see if we have any more questions come in. Paul, I want to thank you for taking the time today and giving us a look at another way to basically do our development and testing, which is very important, of course, to be able to replicate it and do it over and over again and get hopefully get the same results. Or fix those bugs that we find. So
yeah,
appreciate you coming by today. Doesn't look like we have any more questions at this point. I want to thank everyone for attending. I will be putting this up on YouTube as a recording, so you can point to other friends and people to it, and I'll send out a email by the weekend with all the information and stuff. So, and then someone asked if we can post the slides somewhere. So if you could send me a PDF of those, Paul, I'll include it with the recording.
Absolutely, Tom. Thank you so much for inviting me, and thank you everyone in the audience for the good questions. Hope you found it interesting. Thanks, Tom.
Thank you, and have a great day, everybody. Bye-bye.
All right, bye-bye.